identities. Okay, this is actually the reason why we named the sign related to the cosine. A lot of students will mistakenly kind of connect sine with cosecant because they're reciprocals of each other. But the actual reason that we set up the names of the functions the way we did was because if you take the sine of a complement, remember complement means to add up to 90, or in the case of radians, add up to pi over 2. So if you take the sine of pi over 2 minus an angle, this is equal to the cosine of that exact same angle, and the cosine of pi over 2 minus an angle is exactly equal to the sine of the angle. So they're related via complements, and that's why one is called the sine and one is called the cosine. So here we have a sine of a particular angle, and it's asking us to use or apply a cofunction identity. So since this one's a sine, we're going to want to change it into a cosine, and the appropriate angle that would have the exact same value as the sine of pi over 11 would be the complement to pi over 11, which is pi over 2 minus pi over 11. Okay, so now we just do some algebra to make this a little bit prettier. Let's see, cosine of, let's multiply this one top and bottom by 11. So get 11 pi over 22. Multiply this one top and bottom by 2. 2 pi over 22 is equal to the cosine of 11 pi minus 2 pi, means we have a 9 pi over 22. And you can verify on a calculator if you wish, but the sine of pi over 11 is exactly equal to the cosine of 9 pi over 22. Okay, so why don't you pause the video and try this next one. See if you can figure out and apply a cofunction identity that would work for tangent of 26 degrees. Another expression identical to tangent of 26 degrees. Now this is different than a sine or a cosine, so assuming you paused the video and tried it on your own, the first thing I'm going to note is that the tangent of the complement of an angle is equal to the cotangent of that angle. So here we have the tangent of a complement is equal to the cotangent. This one we're clearly in degree mode, and that's why I'm using 90 degrees instead of pi over 2 radians like the previous problem. And similarly, the cotangent of 90 degrees minus theta is equal to the tangent of that particular theta. So for this problem, we have a tangent of 26 degrees, so the cofunction identity, we're going to change this into a cotangent. We wish to find the complement of 26 degrees, so we need to go 90 minus 26. So what is that? Let's see, 90 minus 20 is 70, so minus 6 more would be 64 degrees. So we should be getting the cotangent of 64 degrees to be identical to the tangent of 26 degrees.